closing speaker before we get to the film and intermission. My name is Kate Dickerson. I'm the founder and director of the Maine Science Festival. We had originally planned that I would be up here with my partner in crime, and then his appendix had other things to say about it, so I'm just going to do a very brief introduction into this project. As Niles mentioned, I keep having kind of crazy ideas, and this one was, well, we talked about working with artists. Why don't we just do it on climate change? Because, that seems like a simple thing to do. So the reason why I picked climate change was threefold, maybe fivefold, but I know three off the top of my head. Number one, scientists have known about climate change for ages. The first published paper was 1938. The first peer-reviewed published paper documenting climate change was happening was 1938. In 1856, Eunice Foote, who is my new favorite scientist, hypothesized that climate change would happen, that the atmosphere would warm up if you added carbon dioxide. So this is not a mystery, but clearly scientists have not figured out how to get the message across. So we needed some help. So that was part of the inspiration. Why climate change in the Gulf of Maine, and why 2020 originally? The Gulf of Maine is warming faster than most of the world's oceans, and climate change, as you heard from some of our speakers who are affiliated, the Climate Change Institute at the University of Maine is, as far as I'm concerned, the world's best research institute for climate change. So we've got the experience and the expertise right here. So let's put all of those together and let's cram it all into the head of a composer who is a fantastically wonderful sport, knows nothing about science at the level that I'm going to introduce him to. And let's do it over the span of 4 months. So after those 4 months, he can talk to school kids and ask them what they want to hear in the piece, and he can carry the climate conversation. And Lucas said yes, for reasons not clear to me. He could do this. So we did. We did a deep dive, and I lined up interviews with Bigelow Laboratory and Friends of Cascade Bay and Gulf of Maine Research Institute and Maine Center for Coastal Fisheries. We went to the town of Stonington. We met with the legendary Maine scientist Robin Alden and Ted Ames, and then we met with folks at the Climate Change Institute, and then we also met with Maine Coast Heritage Trust, which was just kind of the icing. Like, I had no idea how important they were to this story. So what you're going to experience now is, I hope, as fulfilling for you as it was for Lucas. We're going to show a short film of all the interviews. I work with incredibly smart and capable people, and one of them said, you're gonna film all these interviews that Lucas is doing, right? And I said, why would I do that? And she just looked at me, and then I said, well, of course I will do that. So a giant thank you to Miranda Bouchard, who clearly saw the value of getting all of this recorded, which is why you're about to experience a really wonderful piece. Then we will have a short intermission while a gigantic orchestra floods the stage, and go from there for the rest of the evening. So thank you for being here. Thank you for allowing us to talk about climate change. And by the end of the evening, hopefully you will understand why we are calling this an exploration of hope in the face of the climate crisis.
I referred back to the Monoloa Curve, which is, Ralph Keeling, who, basically was on top of the volcano in Hawaii, and he was measuring CO2 day in and day out from the 1950s. And if you look up the Monoloa Curve, and it's something that I honestly thought they should post a little sticker on every gas pump to show this, and in which the CO2 goes up and down with this annual seasonal cadence of increases and decreases as the Earth's biosphere takes up the CO2 during their summer, and then they're exhaling the CO2 in the winter. But there's a slope to that curve. And it's the rate of that slope, the rate of increase, which is the concerning part.
The role of greenhouse gases is to provide a blanket. And the blanket, just as if we were to, at night, we sleep under covers, and it keeps us from cooling down. And greenhouse gases act in a very similar way, is that with more greenhouse gases, there's more of a blanket that can then trap heat within the atmosphere, but also some of that heat gets reabsorbed primarily by the oceans. And so there's been a significant warming in the world oceans, particularly since the 1960s. And it's really starting to manifest now. We're seeing that.
So as it's warming, the populations are moving northward and southward towards either poles. And so there's these, just like with trees or any other organisms, there are these biogeographies of where you'd find them distributed. And that map of the biogeographies are changing. So species that used to be able to make it here in this kind of climate is now moving north. So a good example locally is lobsters. Lobsters have moved 2 degrees latitude in the last 30 years. So their center of their population used to be Long Island Sound, and now it's dead center on Maine. The zooplankton populations in the North Atlantic have, for the last 50 years, you've seen those move several degrees northward also. So a good question will be what's going to happen to the polar species, whether they're just going to be driven out because it's going to be too warm for them to survive and they'll just be taken over by some other species. But meanwhile, everything else is just creeping northward.
There was a warm water event in 2012, and that was kind of really big in the newspaper. We had this early onset of the shed of lobsters in like late May, early June. That event was found to be related to hurricanes Irene and Sandy and a couple others that happened the year before. And they brought the Gulf Stream up like almost 213 kilometers to the northwest.
Wow.
So it brought the Gulf Stream, which is basically a very identifiable piece of ocean, of water mass in the ocean that comes up from the Caribbean. And it's salty and it's very warm and muddy, and you can see it. If you fly over it, you can literally see it. It's that distinguishable of a water mass. It came up and wrapped into the Gulf of Maine. So it just increased temperatures by 8 degrees Celsius that year. We've since seen water temperatures come back down. They've normalized. The Gulf Stream has not relaxed back to its 213 kilometer southern position. It's now kind of right up off of Georgia's Bank, and it is slowing the rate that the cold water comes into the Northeast Channel.
So Maine, in many respects, is still probably as pristine as you're going to get on the east coast of the U.S., where one of my concerns is it's getting less pristine. I spent a decade studying harmful algal blooms in the Gulf of Mexico, and now we're starting to see some of those species in the Gulf of Maine.
Wow.
We're having shellfish closures now in the Gulf of Maine. So I think we're at a window in time in the state that we need to get ahead of these problems so that we don't turn into what some of these other states are facing.
Seawater absorbs the atmospheric carbon dioxide that we have been pumping out since the Industrial Revolution. There's a known set of chemical reactions that create a carbonic acid that in turn acidifies the seawater. It doesn't mean that it's becoming like lemon quality acidic. It just goes from a pH that was about 8.0, and we expect over the next 50 years a decrease of about 33% down to a pH of 7.6, which sounds small, except it's the same scale as an earthquake. So an 8.0 versus a 7.6 earthquake, there's a big difference there.
Right. And being from Southern California.
Yes.
You know?
The analogy may be more apt from that region. But from a shellfish perspective or a coral perspective, it means that the bones that they build suddenly get more difficult to put together. Their shells develop in abnormal formations. They're more brittle, they're less dense. It's almost as if you're giving them osteoporosis.
Mostly looking at lobsters, right? So animals that have shells and hard parts and things like that, it's a lot harder for them to deal with an acidic environment than it is like potentially some other animals. I mean, everything has issues, but things with hard shells, that's even worse. As the temperatures change and as all these things happen, if conditions change, it may be this weird one that has an advantage now, right? You need that variation to see who's going to do well. And when you really narrow that genetic variation, that's not good for populations. No. And that's one of the things that is happening, that we're seeing, at least in our tiny, our experiments, that is exactly what's happening. And so it's called this genetic erosion hypothesis, but that is potentially one of the things that could happen, is it's even further making them not able to handle all these weird environmental changes.
So on your question on the climate change at a macro level, there's sort of two camps: how to mitigate climate change and keep it from happening or slow it down. And there's adaptation, right? So there's a whole sets of, how humanity is dealing with those things depends on their own interests and what they're capable of doing. I would say that we're more paying attention with our center around that adaptation piece, about trying to understand as well as we can what those effects might be. The modeling that Carla mentions is what it is, that things are changing rapidly around here. And we actually believe that listening to and taking the observations from these fishermen who are on the water all the time, paying attention to things in ways that you and I probably don't see, is really important information.
As the sea level is rising, the marshes start pushing into other areas. So it's essentially created new marsh area, because as that level comes up, it's intruding into other places. Well, I have a road that goes through what we call the Oceanville Marsh area, and on both sides of that marsh there's ocean. Webb's Cove is on one side, and Inner Southeast Harbor is on the other, and that is slowly turning into, another island. And of course it blocks the road. You've got people living down there. Takes a while for the tide to go down, and then you got to, in the wintertime, we had to clear all the ice cakes off it. But now with that sea level rising and coming to it,
it's going to be cut off.
It's pushing it back, and it's also coming up around the road.
If you come here at the high tide this month, the water is about 2 vertical feet below where we are now.
Seriously?
Yep. And we're in a forest.
Like all the way?
So right up to this road, road itself sits about 2 feet above the highest annual tide. And so that means that with 2 feet of sea level rise, this road is going to be the new shoreline.
The interesting thing about fishing is that it's the ocean is a common property resource, and so in order to use it sustainably, you have to develop governance that works. And in human society, that's always a push-pull. It's not enough to just be an activist. It's not enough just to be a scientist.
We've been reporting the problem for a long time.
Yeah.
Certain people are listening, other people are not. But it's time to stop just hammering on the problem and start looking for solutions, because we're there.
So if you think about, the animals that we talked about out in the Gulf of Maine, they're having to just react, right, to the conditions that are coming their way. But humans are unique in that we have this remarkable ability to predict the future, at least when it comes to our climate. And I'm really excited about the opportunity that affords. It's really challenging because we're so used to making decisions in a way where we really look backwards and we kind of think about how the world used to be, and we don't want to give up on a particular way of doing things. But by kind of embracing the future and really looking towards the future, there's a lot of power there, and I think there's a lot of opportunity.
There's this little orb, it's spinning around, it's going around the sun. It has this tiny, tiny, thin little atmosphere around it, and we've messed with that chemistry, right? And so there's a lot to be thinking about what we're losing in all of that. And yet there are lots of people on the planet. There's an awful lot that we can do if enough of us decide to do it. And it doesn't have to be everybody, but we've got to do something. I've come to this place where I think working at a local level is what everybody needs to do, and that's where the hopefulness is for me.
There are any of a number of great songs you could spin from them. This whole dance of seasonal changes in fishery and in species that are in a location changes all the time. The one that got my attention most was the whole process of climate change in itself. The warming of water has been, if you look at descriptions, it's a steady slope going up and up. And if you look at it more closely, you have a harmonic superimposed on it that's going like this. And then it changes the slope after this most recent increase in temperature.
Yes.
You've got a different harmonic going on it as well. And if you could put all of those together, you'd have a wicked good tune that would end up in a very high note.
Yes.